Hey, Miss Marion here. We are going to go over Unit 7, but we're going to do a couple of lessons together. So I actually made you a note page. Make sure you get that, and we are going to put it into our workbook. But make sure you get the note page first before you try to tape it in, because it's going to make it a lot easier for you. Okay, so make sure you have a notebook. Make sure you have a note page to go ahead and take these notes. All right, so as I said, we are going to be talking about lesson 10 through 12. So these are our I can statements. We're going to be talking about really large numbers and really small numbers, and we're going to be putting them on the number line to kind of understand what these numbers actually mean and what they kind of represent. So our first I can statement is I can plot a multiple of power of 10 on such a number line. I can also subdivide and label a number line between 0 and the power of 10 with positive and negative exponents into 10 equal intervals. I can also write large and small numbers as a multiple power of 10. And I can also apply what I learned about powers of 10 to answer questions about real world situations. A lot of stuff. It sounds really harder than what it is, so kind of bear with me. Make sure you have a note page and make sure you're following along. All right, so here's example number one, example number 2. So we've been talking about powers of 10, but now we're going to go ahead and we're going to put them on a number line, and we're going to go ahead and kind of group it in groups of 10 itself. Notice how over here this is 10 to the 7th. So then what we're going to do is we're going to mark all of these in here as kind of one group of 10 smaller. So we're going to actually group them in, and we're going to be writing them as like 10 to the 6th kind of stuff. So the first point, the first tick mark here is 1 times 10 to the 6th. So this is, I'm going to kind of do it sideways. So 1 times 10 to the 6th. And then the next one is 2 times 10 to the 6th. Then we have 3 times 10 to the 6th. Then we have 4 times 10 to the 6th. Yes, you should be writing this down. Then we have 5 times 10 to the 6th. Then we have 6 times 10 to the 6th. We have 7 times 10 to the 6th. We have 8 times 10 to the 6th. Then we have 9 times 10 to the 6th. And then technically we have 10 times 10 to the 6th. But as we did last week, we know that we can combine those together and make 10 to the 7. So hopefully this makes sense as far as labeling this number line. All right, so let's look at example number 2. And I'm going to actually bring this up so we can actually see it. All right. And with example number 2, notice how we have 10 to the negative 5 here. And so we're going to, again, kind of label this as kind of what we did before, but we're going to be doing with a negative exponent. So let's think about a number line, right? Just a normal number line. And we're going to have 0, we're going to have 1, we're going to have 2. But remember, we have a number line and it looks like this. So just as we kind of did before, we want the bigger number kind of on the right-hand side of this number, of the number line that we're going to label. And then we have if we look at them this way, right? Up here, we had 6s all here, and then eventually we made a 7. So I need something that's smaller than 10 to the negative 5. Well, if we look at it, it's all going to be 10 to the negative 6. So let's go ahead, let's kind of do the same thing, but we're going to be 10 to the negative 6 kind of stuff. So we're going to have 1 times 10 to the negative 6. We have 2 times 10 to the negative 6. We have 3 times 10 to the negative 6. We have 4 times 10 to the negative 6. We have 5 times 10 to the negative 6. We have 6 times 10 to the negative 6. We have 7, 8, 9, 10 to the negative 6. And then technically we have 10 times 10 to the negative 6. And if we think about what we did last week, that's technically 10 to the 1, 10 to the negative 6, and we added those exponents together. 1 plus a negative 6 makes the negative 5. So kind of keep it in mind, we're doing like number line kind of stuff. All right, so you need to go ahead and turn the page over, and you're going to actually see this example number 3. We are going to go ahead and we're going to take all of these numbers, and we're going to put them on the number line that goes from 2 times 10 to the 8th all the way to 3 times 10 to the 8th. So 2 times 10 to the 8th, 3 times 10 to the 8th, and now we have 1 times 10 to the 8th, 2, 3, all these have times 10 to the 8th, and then notice how this one is technically 10 times 10 to the 8th, which is 10 to the 9th. Okay, so we were using that same kind of number line that we did before, but we're going to go ahead and plot these points on that number line. But first of all, I need to, so notice how these two go together. See how this is 2 times 10 to the 8th, and then notice how this 3 times 10 to the 8th, it's also down here. So notice how there's extra tick marks that go along with this number line. And we're going to go ahead and we are going to label this, but we're going to label it between 2 and 3. So if we look at it, this first one that's here, so notice how the 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it makes a 10. Okay, so I'm going to label the first one going along here. I'm going to label the first one as 2.1 times 10, and then notice how we have an exponent of 8. We're using that same one. Then we're going to do 2.2 times 10 to the 8th, 2.3 times 10 to the 8th. So notice how we are going up just that decimal point between 2 and 3, that tenth position. So 2.5 times 10 to the 8th, 2.6, 2.7, 2.8, 2.9, and then notice how we have the 3.0 times 10 to the 8th. Okay, so notice how this piece is a blown up piece between these two. So we took this 2 and we made it bigger and it came down here, and notice how we're doing all the decimals between 2.0 and 3.0, 2.0, 3.0. Okay, so now we're going to go ahead and we are going to look at our numbers. And so first of all, we have space. Space is 3 times 10 to the 8th. Well, we can go ahead and plot that point. So right here is space. And notice how this one is the same. That is also space. They're the same number. Now let's go ahead and let's go do copper. 2.8 times 10 to the 8th. So do I kind of put it in here? Oh, notice I have that down here. This here is going to be copper. All right. Ice. Ice is 2.3 times 10 to the 8th. So 2.3. So this is ice. All right. I guess I did these out of order, but here's water, 2.25 times 10 to the 8th. So I have 2.2, 2.3, I have 2.25. So that's going to be a little bit closer to here. So this one is water. Then we have diamond, 1.24 times 10 to the first. So is it going to go between 2.0 and 3.0? No. Is it going to go between 0 and 1? No. Is it going to go from 1 times 10 to the 8th to 2 times 10 to the 8th? Oh, it's 1.24. Yeah, it's going to be here. So, and it's going to be closer to 1. Diamond. I guess I'm going to have to write on the words. Okay. And then the last one is olive oil. Olive oil is, and I just wrote on that. Let's erase that. So it's 2 times 10 to the 8th is olive oil. So that's going to be here. How do I spell it correctly? I just put oil there instead. Let's do olive oil. So notice how all these different numbers correspond to this this number line, and notice how this part down here is zoomed out from these 2 points here. All right, so we have example number 4. It says finish the numbering the number line and then state the exact value for point A. So again, notice how we have negative exponents. So we're going to have it all of these. So instead of doing negative 10, we have to do a number that's smaller because it's negative. All of these are going to be negative 12. So let's go ahead and let's plot the points. So this one is 1 times 10 to the negative 12, 2 times 10 to the negative 12, 3 times 10 to the negative 12, 4, 5, here's 6, negative 12, here's 8 times 10 to the negative 12, 9, technically 10 times 10 to the negative 12, but if we put that together, that is 10 to the negative 11, okay? Then notice how, again, this is a zoomed in piece. See these two here? This part is a zoomed piece from here, so that means they go at the end. So let's move this up so we can see it a little bit better. So this one down here corresponds with one above. So this is 6 times 10 to the negative 12. Down here is 7 times 10 to the negative 12. And then we're going to put the decimal points in between. So this one is 1 times 10 to the negative 12. Here is 6.2 times 10 to the negative 12. 6.3. Let's erase that. 6.3 times 10 to the negative 12. 6.4 times 10 to the negative 12. 6.5, 10 to the negative 12. 6.6, 6.7, 6.8, 6.9, and then notice how we have 7 or 7.0 times 10 to the negative 12. Okay, so it first asked us to go ahead and plot the points, right? Plot stuff on the number line. Let's go back and read that. Oh yeah, so finish the number in the number line, and then we need to figure out A. A is this one here. So we're going to say A equals 6.1 times 10 to the negative 12. So if this is a little confusing, make sure you go back, like pause it, go back, watch it again, and then figure out what it is. All right, so these two slides are from the right-hand side of the page. I wanted to put them on the same slide together because we're going to reference back and forth to them. But here, example number 5, here are the approximate population of 3 cities expressed in the scientific notation. We have Chicago, 2.7 times 10 to the 6. We have Phoenix, 1.6 times 10 to the 6. And then we have Honolulu as a 3.4 times 10 to the 5th, okay? So what we're going to do is we have to number the number line. Notice that we have 10 to the 6th, 10 to the 6th, and then 10 to the 5th. What we need to do is we need to start this number line with the highest exponent. Highest exponent is going to be 6. So again, we're going to take this number line and we are going to label it with the highest exponent. Actually, it's a kind of the bigger exponent. So remember, the last one is always like 10 times 10 to the 6th, which is actually 10 to the 7th. Okay, so remember number line, we're doing the number lines there. And then now we're going to go back, kind of backwards. This is 9 times 10 to the 6th, 8 times 10 to the 6th, 7, 6, 5, 4, 3, 10 to the 6th, 2 times 10 to the 6th, and then 1 times 10 to the 6th. Okay, so again, if you don't understand that, you need to go back and look at it again. But notice, again, we want 10 to the 6th because that's the highest of the two. Remember that 10 times 10 to the 6th equals 10 to the 7th. So the 10 to the 7th goes here, and then you go backwards every single time, kind of like how we did before. So now we need to go ahead and we need to put the different cities on the number line. So Chicago is 2.7 times 10 to the 6th. So 2.7 is going to be between 2 and 3. And that's kind of going to be in the middle-ish, kind of, because it's 2.7, right? So here is where Chicago, right? And then now let's plot Phoenix. Phoenix is 1.6 times 10 to the 6. That is going to be between 1 and 2, kind of in the middle. So this is Phoenix, O-E-N-I-X. And then we have Honolulu. All right, and so we're going to go ahead and we're going to plot that. Notice how this is 3.4 times 10 to the 5th. So all these are 10 to the 6th, right? So we're going to put the Hawaiian Island, right? This is the 3.4 times 10 to the 5th. Okay, so remember, we're looking at the exponents. This is 5. All the other ones are 6, so that needs to be here. Right, so that's where Honolulu actually goes. There is because it has an exponent of 5. That means it needs to be smaller than the 10 to the 6, but not past 10 to like the 0 kind of stuff. And honestly, it should actually be closer, kind of really, really close here. But we understand that kind of stuff. So we're just looking at exponents, kind of where they go on number lines. So now we're going to go ahead and we're going to look at the next part of this. So if we look at B, so we're looking at our number line, and it says true or false. About 8 times as many people live in Chicago than Honolulu. 8 times more. Let's think about that. How do we go ahead and figure that out? So it's asking 8 times more. So for us to go ahead and do it backwards, we're going to actually do opposite of times. Oh, that's divide. So if we look at it, Chicago is bigger because it has an exponent of 6. Honolulu has an exponent of 5. So we're going to take the Chicago stuff, Chicago, and we're going to divide it by the smaller. So Chicago is 2.7 times 10 to the 6th. Honolulu is 3.4 times 10 to the 5th. And what we're going to do is we're going to put this in our calculator, and we're going to put parentheses around it. So go ahead and put that in your calculator, 2.7 times 10, like caret 6, right? We've been doing exponents. Put parentheses around it. Divide 3.4 times 10, caret 5, parentheses. And then this equals 7.941176471. And it's asking that it's about 7. Sorry, it's about 8. Is 7.9 about 8? Yes. So this answer is true. So again, if you did not understand something, make sure you go back, rewind it, go through it again, and go ahead and figure it out that way. All right, so we're actually going to, for today, we're doing 2 sets of practice problems because, again, we went through 2 lessons. So we're going to do lesson 10, and 1, 2, and 3. Please make sure you check Canvas for number 1. I kind of changed that just a little bit. And so there's some review stuff in there too. And then we're doing lesson 11, numbers 1 and 2. So make sure you do these. Make sure you put the answers into Canvas. And I will see you later. Have a good day. Bye.